Okay, the home play for tonight, once again, page 363 only. 363. And today is going to be one of those days that it's going to go super fast to stay focused, and I need you here. Because we're going to cover everything that we've seen for the first semester and everything that we've covered in regards to factoring and all the different types of approaches. Now, the book, once again, does not show a lot of the connections. Today, I'm going to start slow once again. We're going to keep going, and then from there, you'll see how everything connects, all right? Here it goes. Our objective for today can identify rational and complex zeros of polynomial equations. Once again, I can identify rational and complex zeros of polynomial equations. What do we do these past 2 days? Rational zeros. And what do you notice today? Complex zeros. Everybody with me? So, we don't need a prior model since we know what polynomials look like. There they are. We already introduced zeros and rationals, but let me refresh your memory in regards to the rest of the numbers. Here it goes. Writing utensils down, look up to the screen. At the beginning of the school year, I introduced real numbers, and I said, all right, guys, we already covered real numbers, but here it goes one more time. Real numbers are broken into two, rationals and irrationals. Rational numbers have the different ones. The first ones are counting numbers. The second ones are whole numbers, which are counting numbers including zero. From their integers, which is all of these, including their opposites. But it also includes all the ones that are fractions and decimals. Those are rational. But all of these together are still real numbers. Are we there? Irrational are any number that cannot be written as a fraction. And I said, let me give you some examples. And I said, we can talk about those later. And we've seen some of these. We've been using sometimes square root of 2. We haven't really used pi or square root of pi. Phi is the one that I told you that it's like our, that's in our DNA, and I talked to you a little bit about that, and E, we'll talk about that later. However, I said, that is real. And then I said, imaginary are different, and they look like this. And I said, what is so particular about this? That it has a what? A negative. We cannot take the square root of a negative number. And we concluded that square root of -1 is I. However, I have everything, once again, everything we do in this class has a purpose. As well as this table that I put together, the purpose was, yes, can you wait for him outside, please? Thank you. The purpose of this is that whatever's on the left stays on the left, whatever's on the right stays on the right. So to create a new problem, check this out. A new number. The new number that we're going to look at today is complex numbers, and we already saw these. However, before I get there, how do I make this into an imaginary? I told you to do square root of -1 times 16. What do we know this? Square root of 16 is 4, and square root of -1 is I, so this is what? 4i. That's why from now on, instead of doing all this work, we just say 4i. Therefore, if I have square root of -49, so you never the imaginary of that. 7i, that is correct. How about square root of -25? 5i, and so on and so forth. So to make it complex, I take a real number, 23, and I take an imaginary number, 7i, and now we have a what? Complex number. Is it coming back, yes? Okay, we're going to be using complex numbers today using in regards to our polynomials. So I just wanted to make sure that we are there, okay? With that said, copy this, please. Example Q. Find the zeros of the polynomial function and graph. F of x equals x squared plus 2x minus 8. Once again, it says, example Q, find the zeros of the polynomial function and graph. Now, once again, the book doesn't ask you to graph. I asked you to graph, so I want to make sure that you're understanding everything from the get-go as it connects. Here it goes. What is the first thing we know to do when we're solving these? We need to make it equal to 0. So write everything down. X squared plus 2x minus 8. What did we do the other day in regards to finding our zeros? We needed factors, didn't we? So what do we do here? Factor. -8 and 2. Factors of 8, 1 times 8, 2 times 4. Which one of those pairs adds or subtracts to give me 2? 2 and 4, so I write 2 and 4. But one of them has to be a negative in order for this to be a negative. The 2. How do we know that, Mr. Q? To make it a lot faster. Whenever you have a negative on top, and this tells you the sign of the biggest of the two. What is the sign of this number? Positive, so that means the biggest will be a positive. If this was a negative, well, guess what the 4 would be? Negative, and so on and so forth. All right, let's rewrite this. So this becomes x squared. Bring down the last term, negative 8. But now instead of 2x, what do I write? Negative 2x and positive 2x. Negative 2x, positive 4x. Let's group these two. And what is GCF for these two? X, we're left with x minus 2. GCF for these two is 4. We're left with x minus 2. So, what's the same here and here? X minus 2, that's my first factor. And what's left? Well, I have the x and I have a plus 4, so that becomes x plus 4. And all that equal to 0. Is it coming back? Yes? All right, so therefore at this step we do what? X minus 2 equal to 0 and x plus 4 equal to 0. Let's solve. Plus 2 plus 2. X equals 2 minus 4 minus 4. X equals negative 4. And these are called zeros. Why? Because if we were to substitute them into the equation, what do we get? 0. All right. So far, so good? All right. Here we go. Let's graph. That's why you should save. Okay. Get your graph in front of you. Label the first coordinate plane. Label it Q so that you know it references to example Q. Here we go. The first 0 is 2. 1, 2. Plot your point. There it is. The other one is negative 4. 1, 2, 3, 4. Plot your point. Now, for quadratic functions and equations, listen up. Who remembers what the last term is called? Our constant, but it's also our y-intercept. Our y-intercept. What that means is that on our y-axis, we're going to plot a point on negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Plot your point, negative 8. All right, before we graph this, okay, you already have your 3 points we can graph it, but let me show you something really quick to refresh your memory. Look up, write your pencils down. When I covered the anatomy of functions not too long ago, I said, we started off with y equals x. X is to the first power. That graph looks like this. Notice it starts down here and it goes towards the right and up. From there we went to y equals x to the second power. What does that look like? A parabola. Starts at the top and it ends at the top. Oh, it goes from left to right. From there we went to y equals x cubed. And it goes like this. Starts at the bottom and it ends at the top. From there we went to y equals x to the fourth. That one looks like this. But it starts at the top and it ends at the top, but on the other side. And you go to y to the fifth. Oh, sorry. Y equals x to the fifth. And that looks something like that. And then y equals x to the sixth. So, and I said when we covered this, especially those that were like taking notes like if it was today. Look at this. Odd, odd, and odd. They all start at the bottom and they end up at the top. Start at the bottom, end at the top, start at the bottom, end at the top. You guys notice that pattern? And all the even number exponents, look at this one. This is to the second power. It starts at the top left and ends on the top right. This one, top left, ends at the top right. This one, top left, ends at the top right. So if that's true, check this out. What power is this to the second? That means it starts at the top left and ends at the top right, which means I start from over here and I'm going from left to right. There it is. It might not look pretty, but I want you to connect those three and make it look like a parabola. So let's see. Did we find our zeros? Yes, here they are. Did we graph our function? Yes, and we use the zeros and the y-intercepts. Yes? All right. Copy this next one. See if you can do this next one by yourself. Example, super Q. I mean, mega Q, my bad. F of x equals x squared plus 2x minus 3. F of x equals x squared plus 2x minus 3. F of x equals x squared plus 2x minus 3. I'll give you some time. Copy and go. All right, check your work. Zeros, x equals 1, x equals negative 3. And there's your graph. Hands if you got that. Let's go. Continue. Example, super Q. F of x equals x cubed plus 6x squared plus 5x. F of x equals x cubed plus 6x squared plus 5x. And let's do come together. Here we go. What's our first step again? Equal to 0. X cubed plus 6x squared plus 5x. Uh-oh, we have a dilemma here. This is a cubic. So on this one, I can't use power. And there's only 3 terms, so I can't group. Synthetic division? Oh, no. Oh, yeah. However, what do I need for synthetic division? We don't have a constant. So don't say it out loud. Look at it. Look at each term. What can we do? Talk it over to your neighbor. What can we do? Look at each term. Who sees that each term has an x? Therefore, GCF is x. And we're left with x squared plus 6x plus 5 equal to 0. Now, can we factor this one? Yes. 5, 6. Factors of 5 that add up to 6. Very good. 1 and 5. So let's rewrite this. X squared plus 1x plus 5x plus 5. Let's group this and this. GCF here is x. We're left with x plus 1. GCF here is 5, and we're left with x plus 1. Therefore, what's the same here and here? X plus 1. And what do we have left over here? We have x and the positive 5, so my other factor is x plus 5. Don't forget your BFF. What's your BFF? X and all that equal to 0. How are we doing? We still haven't found the zeros until we set each one of these equal to 0. X equals 0. X plus 1 equal to 0. X plus 5 equal to 0. Let's solve. This one's already solved. Minus 1 minus 1. X equals negative 1. Minus 5 minus 5. X equals negative 5. Now we have zeros. Okay. Yes. Let's graph this one. Very good. Bam. Ramon for Presidente. It's the constant. What's our constant? 0. All right, so let's graph it. Our 0 is there, negative 1, and negative 5. Now, let's think of how this looks. This is a what? A cubic, which means it goes something like this, yes? Starts down here, ends over there, but we have to go through each point from left to right. So if we start down here, what's the first point we're going to go through? Negative 5, and then negative 1, and then 0, and we're done. Is it making sense now? Everything that we've done in the first semester and all this, it's starting to connect. Yes, Mr. Q, we love these. All right, good. Okay. Yeah, you are going to do another one. Show me the thing what's up to you are with this. Okay. Copy this next one. See if you can do this next one by yourself. Example Shazam Q. F of x equals x cubed minus 8x squared plus 7x. F of x equals x cubed minus 8x squared plus 7x. Once again, f of x equals x cubed minus 8x squared plus 7x. Copy that and go. I'll give you some time. Work. I'm going to graph. Since it's a little bit different than the other, I don't want people to get confused. Here it goes. The 0, 1, 7. I'm still going from left to right, starting with a point, the very first point on the left. Where do I start? At 0. So I go up, down, and up again. Hands if you got that. That is correct. Show me the feelings that come to you up to right there. Okay, good. 5s. I'm sorry? Yes. Yes. Example Super Duper Q. Copy this one. Crank it up a notch. Focus, focus. F of x equals x cubed plus 2x squared plus 3x. All right? By now our noodle should be doing automatically the first step, which is equal to 0, x cubed plus 2x squared plus 3x. The second thing our noodle should be doing automatically is what? Greatest common factor, which is x, and we're left with x squared plus 2x plus 3. Automatically at that point, our noodle is going to do what? We got 3 and 2. Factors of 3 that add up to 2. Tell your neighbor, please. Wait a minute. Wait. I'm hearing negatives and stuff. This is not a negative. Okay, so what factors of 3 add up to 2? 1 and 2? 1 times 2 is 3? Okay, let me clarify that. Factors of 3, 1 times 3, are there any other? Does that add up to 2? No, therefore there is none. So what are we doing, Mr. Q? All right, you're going to love this part. Check this out. I'm focusing right now here. When we can't factor, who remembers? Minus b plus minus square root b squared minus 4ac over 2a. Yes, that's right. Minus parentheses plus minus square root. Oh my goodness, fly you bug. Parentheses squared minus 4 parentheses over 2 parentheses. All right, here we go. I'm going to label this trinomial. Look up. This trinomial I'm going to label underneath so I know what's what. A, B, and C. Does everybody see what I did? Here we go. What is A, everyone? Everyone, what is A? 1. So therefore I label 1 there and 1 there. What is B? 2. So that goes right there and right there. And of course the last part is C, which is right. Oh, sorry. Nice. Does everybody see what I did? All right, here we go. Let's simplify. Negative times 2 is negative 2. Focus, please. This is going to go pretty fast. 2 squared is 4. Negative 4 times 1 times 3, that's negative 12 over 2. Let me simplify again. Negative 2 plus minus square root of negative 8. Is that correct? And all that over 2. All right. Did you guys notice that? Man, Ramon's on the ball today. Who notices that this is a square root of a negative number? It's an imaginary. But we need to factor it so that we can actually extract the imaginary number from it. Look up. Look what I'm going to do. I'm going to rewrite this. Negative 2 plus minus square root of negative 4 times 2 and all that over 2. And I'm going to rewrite this again. Negative 2 plus minus divided by 2. So now, let's see. Help me out. Does everybody see the imaginary? Yes? What is square root of negative 4? So write that in here. 2i. What is the only thing we cannot take the square root of? 2. So that stays as square root of 2. Are we there so far? Since now we already have our radical and we have our imaginary, now we can simplify if we can with a division. Can we divide this by this? Can we divide this by this? Yes. So what is negative 2 divided by 2? Negative 1 plus minus. What is 2i radical 2 divided by 2? I radical 2. Okay, but I'm still not done. I need to write my factors for this. There's 2 of them. Let me show you the 2 of them. Hold on, hold on. Here's the first. And the second one. So the first one is negative 1 plus I square root of 2. And the second one is negative 1 minus I square root of 2. I'll show you right now. All right, and don't forget what? Our BFF, which is x equal to 0. All right, we're almost done. What's the next step, everyone? Equal to 0. Okay, here we go. So we write x equal to 0. Negative 1 plus I square root of 2 equal to 0. And negative 1 minus I square root of 2 equal to 0. Now, when we get to these parts, this part right here, look up please. We will not be able to graph because they are imaginary. We only have how many real numbers? 1, the rational one. So what I want you to do at this point, all I want you to do is tell me what you have. What do we have? 1 rational 0. Point to it. And what else? Comma. 2 what? They're not just imaginary. They're called what? Complex zeros. That tells me that you understand what you're looking at. Does that make sense? Yeah. Yeah. But if you guys notice, now we're starting to use all the little, all the theorems, all the forms, all the different styles of factoring and such that we've been using in the past. Now they come to play in today's lesson. Okay? All right, here we go. So let me recap. We started off with a qubit equal to 0. We factored out the GCF. We couldn't factor, so then we needed to do something else. What did we do? Since it was a trinomial, I was able to use the quadratic formula. I substituted values, but I ended up with complex numbers. So I ended up writing my 2 factors, including the rational, equal to 0, set each one equal to 0. So that's how I found my zeros. 1 rational 0 and 2 complex zeros. Okay? Copy this one. Example 1. Yes. It reads, f of x equals x to the 4th plus 3x to the 3rd minus 4x to the 2nd minus 12x. All right? Step 1. Carlo. equal to 0. Thank you. X to the fourth plus 3x cubed minus 4x squared minus 12x. At this point, look up really quick. Your noodle might want to do what? Since it's a big polynomial, it might want to do synthetic division. But what do we need for synthetic division? A constant. We don't have a constant. Therefore, what is the next step? Lene. Not yet. Before that. What was the second step? Very second step.
Oh, the x.
The x. We factor out an x. That's the GCF. Let's see if it works. Yes. That's x cubed plus 3x squared minus 4x minus 12. And all that equal to 0. So let's look inside of the parentheses. What do we have? A big polynomial, but do we have a constant now? What can we do? Synthetic division? Yeah. However, there's some lazy people in here. Let's see, where are my lazy people? Let's see. Own it, own it. All right, Jake, if you didn't want to use, pay attention to this. Listen up. If you didn't want to use synthetic division, what else can we do with these four? Help them out. Who's got it? Daniel. Group. That is correct. Let's see if it works. What is GCF for these two terms? X squared. I'm left with x plus 3. What is GCF for these two? Negative 4. And I'm left with x plus 3. And it did work. Bam. Daniel for Presidente. So this and this is x plus 3. All right. What do we have left? We have left the x squared and the negative 4. I'm going to write it here. X squared minus 4. Look up. Who recognizes that we can rewrite this in another way? Talk it over your neighbor. How can we rewrite this one another way? Yeah, it's a shortcut. It's a little shortcut. Who's got it? Lauren? Square root, so we end up with x plus 2, x minus 2. That is correct. Lauren, let's go. Bring down the x plus 3, and don't forget about the BFF. What's the BFF? X, and all that equal to 0. Let me ask you a question, guys, really quick. Look up, look up, look up, look up. What if grouping didn't work here? We would have to do synthetic division. Let me repeat that again. If grouping didn't work here as what we did here, we would have to do synthetic division. 1, 3, negative 4, 12, and then do the long synthetic division to find our factors. All right, let's continue. Are we done? No, let's find our zeros. X equal to 0, x plus 3 equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. This one's already solved, therefore minus 3 minus 3, x equals negative 3, minus 2 minus 2, x equals negative 2, and plus 2 plus 2, x equals 2. All right, and these are our zeros. Question, do we have any complex numbers there? No, which means we can graph this. So let's graph it. Get your graph in front of you. Here we go. 0, negative 2, negative 3, and 2. What kind of power is this? An even power. That means we start at the top left and we end up where? On the top right, and we have to go through each of those points. So here we go. Let's start here. We go through negative 3 from left to right, and then through negative 2, and then down, and then up. Bam. Let's go. Be nice. How we doing? Show me if you're going to come through out with these. Yeah, we got this. Yes? Okay. Let's do another one. Example 1Q. Copy that. We got g of x equals x to the fourth plus 2x cubed minus 9x squared minus 18x. All right. I'll give you a little bit of time. I'll give you a head start. Ready, copy, and go. All right. Check your work. All right. Hold on. Don't put it away yet. I need you to copy one more thing. 0, -2, -3, +3. Hands if you got that. Okay, good. Now check this out. You might encounter something like this. You don't have to copy this, just pay attention. Here it goes. 0 equals x to the fourth plus 4x cubed plus 13x squared plus 36x plus 36. X cubed plus 4x squared plus 13x. Oh, what? Hold on. Plus 36. Where was I? Plus 36 plus, wait a minute, two different constants? Wait a minute, GCF is not x? There are no combined? What do you say, Jake? Because now we have a constant, we can do synthetic division. Bam, let's go. Good one, guys. Home plays on page 363. Oh, 363. Have a good one, guys. See you guys tomorrow. Bye.